All right. So this video is about the next type of function that we're going to be studying and graphing and analyzing. And that's actually two different graphs, and we're going to look at cubic functions, x to the third power, and cube root functions, which is y equals the cube root of x. So first things first, we're going to go ahead and go to Desmos and see what these graphs look like. So go ahead and get your Chromebooks out, get Desmos all pulled up on your Chromebooks. And we're going to type in first y equals x to the third power. Remember to do your exponents. You're going to hit Shift 6 to do that little up arrow, the caret button, Shift 6. And then for us to be able to get our table of values, I'm going to click up here where edit list is. And then I'm going to click on the table. And the default table is exactly what we want to fill in for our notes here. So you can see on your notes that we've got this part right here. So you can look at Desmos and you can fill in this table exactly using what Desmos says. So it has -2, gives an output of -8, -1 gives an output of -1, 0 gives you 0, 1 gives you 1, and 2 gives you 8. And then we can go ahead and we can plot all of those points. So you can use Desmos to see what those points are looking like. I'll zoom out a little bit so I can see them. There we go. So go ahead and take a moment and just graph all of those points. And when I graph this, I like to think of it as kind of like half of a U that goes up and then half of a U that goes down, kind of like that. So our transformations are going to be exactly what we are used to. So the A value in the front can be negative. And if the A value is negative, that means that the graph has been reflected over the x-axis. If the A value is greater than 1, I'm putting it in an absolute value sign because it doesn't matter if it's a positive or a negative A, it just matters about the size of the number. So if the A value is greater than 1, then that's a vertical stretch. If the A value is less than 1, it doesn't matter what the sign is, but if it's less than 1, it's a vertical compression. So just like what we're used to. The inside of the function, those H values tell us if the graph is moving to the left or right. So a positive H tells us that the graph is moving to the left. A negative H tells us that the graph is moving to the right. And then on the end, the K value still means what we remember. So a positive K means the graph has been shifted up. A negative K means the graph has been shifted down. These graphs do not have a vertex. They still have a middle point. You can see it right here, but you don't call it the vertex. We're going to call it the locator point. Locator point. It's kind of like the middle point. If you call it a vertex ever on accident, I will not mark you down. We're going to find it the same way that we've always found it in the past. It's going to be the H value and the K value. So the opposite of this sign and then that number. So I'll always write LP for short. All right, so first example, given this equation, find the transformations and the locator point and then graph the function. So here we have a vertical compression of 1/2. The graph has shifted to the right 1. And it has shifted up 5. the locator point is +1, +5. So I'm going to go to the right one and up 5. There's the locator point. And then I'm going to go ahead and graph this on Desmos so that I can get the rest of the points. So I'm going to be typing in y equals 1 divided by 2. 1 divided by 2. And then x minus 1 to the third plus 5. Okay, I'm going to go up here, edit list, click on the table. I'm looking for the point 1, 5. And then from that middle point, I need to have a couple points on either side. So I'm just going to get the table to give me some more points here. Want some more points in this direction. And I can graph decimals. That's okay. 4.5 is not going to be terrible to graph. 8.5 isn't terrible to graph either. So I'm going to go ahead and going to graph the middle right here. These 2 points are good. This point, these 2 points are good. I could graph this point. The next point higher, I could graph that, 3, 9. Oh, I can't go much higher than that though. So the ones that I can see on the screen are the ones I'm gonna graph. So I'm gonna go ahead and start drawing those. Let's see, what can I do next? 1, 5. So I'm gonna do 2 and then 5.5. And I'm gonna do 0 and 4.5. Those are all really together on our grids. Let me show you. There we go. And then we had 3, 9. Let me check Desmos for the other points. 3, 9, -1, -1. Sorry, -1, +1. There we go. And then -2, -8.5. Okay, so from the middle, there's my U shape going up. And then there's my U shape going down. Okay. All right. Next, we have a cube root function, y equals the cube root of x. So we're going to graph this on Desmos and get some points for the table. So the cube root is a little bit more complicated to graph. So when I type this in Desmos, I just have memorized how to type a square root and type a cube root. And we talked about square root, to type that in Desmos, that is SQRT, or you can come down here where the keyboard is and you can hit the square root. For the cube root, same idea. You can type CBRT and a cube root will pop up. Or I'm guessing it's here in functions. Let's see, cube root, cube root, cube root. Any cube roots? It's right down here. You'd click on this. So you'd go on functions, click on this one, and then it will tell you, it'll give you a space to put the 3 in for cube root. So you can do it either way. CBRT is how you'd get a cube root. Okay, so there's the cube root function. You can see that it's just like a cubic function. It's just kind of on its side instead. I'm going to click on the list, edit list. I'm going to make it a table. And then I want you guys to see, we're going to add some values here, lots of decimals. And then all of a sudden I get a good number there. So I'm going to do the same thing up here with the negatives. -2, -3, -4, -5, -6, -7, -8. So 8 is kind of the magic number. And if you notice, it was kind of the magic number on the last one as well. So if you look back over here, when we plugged into, we got 8. So it's just the reverse for a cube root. So if you plug in -8, you get -2. If you plug in -1, you get -1. So what I'm doing with the cube root function is I'm just looking for values on the table that are easy to plug in. And are going to be easy to graph. So I did -8, -2. I skipped all of those decimals, and then I did -1, -1. Next, I'm going to do 0, 0, 1, 1. And then I'm going to skip all the decimals, and then I'm going to go to 8, 2. So I'm just going to write down the ones that are easy to work with. So 0, 0, 1, 1, 8, 2. So these are kind of going to be a pain when you have to graph them on Desmos, because you're going to have to skip a lot of values to be able to find the ones that you want so that you can graph them. So -8, -2, -1, -1, 0, 0, 1, 1, 8, 2. And again, this is like half of a U going in one direction, half of a U going in the other direction. The transformations work the same, so if you want to write them down again, you can, but we're still going to have the A as, if it's negative, it's a reflect over the x-axis. If it's bigger than 1, it's a vertical stretch. If it's less than 1, it's a vertical compression. If your H is positive, it moves to the right. If it's negative, it moves to the, if it's positive, it moves to the left. If it's negative, it moves to the right. If your K is positive, it moves up. If it's negative, it goes down. Locator point is still HK. So for the transformations, I'm just going to say take these and bring them down here, because I don't feel like writing them again. Okay, all the transformations are the same. All right, so let's move on to the next example. So here, example 2 says 4 times the cube root of x minus 6 plus 2. So the transformations would be vertical stretch of 4, shift to the right 6, and up 2. And the locator point would be +6, +2, +6, +2. So I'm going to go over 6, up 2. There's our locator point right there. I'm going to go ahead and get this typed in on Desmos so I can graph it. So we'll get rid of this one. That one. Okay, so y equals 4 CBRT x minus 6 plus 2. Okay. And then I'm going to go ahead and turn this into a table. And I'm going to look for the point 6, 2. So +6 is going to be more of the higher value. So I put my cursor after the 2, and I'm going to press enter a bunch of times. Okay, so here's 6, 2 right here. That's the middle of the graph. And so now I've got some points on either side that I can graph pretty easily. I've got 5, -2 that I'm going to graph. And then I also have 7, +6 that I'm going to be able to graph. So I'm going to go ahead and graph those. And then I want to see if there's any more points that I can graph. Looks like with these points right here, we're getting pretty big pretty fast. I just got to 12, so I'm off the graph now. 14 for an x coordinate before I get to a y coordinate of 10, so that's off the graph. So I'm going to go in the other direction. -2, -6, I can graph that. -2, -6 can be graphed. So I'm going to go ahead and just show you what I have here. There's my points. I'm going to remember using Desmos kind of what the graph looks like. So we've got kind of a U shape going this way, kind of a U shape going this way. Okay. All right, so the rest of the notes, now that we know how to graph them, find the transformations, we don't have a vertex for this graph, but there's a point that's similar in nature. This is the locator point, so we know that the locator point is HK. We know the domain and the range. We've learned that before. That's our X and our Y values. I'm going to put the X and the Y out here so I don't forget. So the vertex, for example, 3, and it's not going to be the vertex, it's going to be the locator point. The locator point, for example, 3 is -1, -3. -1, -3. Okay. For the domain, I'm going to look at my x values. I'm going to look how far the graph goes to the left and how far the graph goes to the right. And to the left, it goes forever. There's a left arrow. To the right, it goes forever. There's a right arrow. So the domain is from -infinity to +infinity. Right? Next we have the range. So we're going to say how far down does the graph go? How far up does the graph go? And the graph goes down forever and it goes up forever. So we're circling the same parts, but now we're thinking about our y values for the range. The graph goes down forever and the graph goes up forever. Okay, so that's kind of boring answers for those, but it'll be kind of boring because these graphs look like that. Next, we're looking at increasing intervals and decreasing intervals. So these are the x values, always using x values. These are the x values that make the function go up or the x values that make the function go down. And here, I made the graph, if we didn't print it in black and white, if we printed it in color, it would have a pretty color here, but you can't even hardly see it when it printed on this blue paper. That's what the graph looks like. So if we were to put a stick figure right here, he would be walking downhill and he'd be walking downhill very steeply. So this graph is definitely just decreasing. And it starts at a left arrow. So it starts at -infinity and it decreases to a right arrow. And the arrow mostly goes down, but it does go to the right. It just doesn't go to the right very fast. So this is an up arrow that also goes left. This is a down arrow that also goes to the right. So for increasing intervals, I'm going to say none. This graph does not go up at all. Decreasing, it goes down really fast the whole time. So I'm going to say it decreases from -infinity to +infinity. Okay. Over here, maximum and minimum, look for mountaintops, look for valleys. These graphs don't have mountains or valleys. So we're going to say none and none. No mountains, no valleys. In fact, for cubic graphs and cube root graphs, we're never going to have mountains or valleys. X-intercepts and Y-intercepts. I'm going to go ahead and graph this on Desmos so that I can see the graph and get the X and the Y-intercept. So you can kind of see them on there, but it looks like they might be decimals. So let's go ahead and plug it in here. So I'm going to type in y equals 1 divided by 3, x plus 2 to the 3rd power plus 1. Okay, so there's the x-intercept, there's the y-intercept. So my x-intercept is -3.4420. My y-intercept is 0, 3.667. All right. Next, they're asking, is the graph continuous? How do we determine if these graphs are continuous? And just a reminder, graphs are continuous if you can trace the whole graph with your finger without picking up your finger. So can I trace this whole graph without picking up my finger? And the answer is yes. It's always going to be yes for these drawings. So the graphs that are continuous here, square root, which is actually on the next set of notes, but cubic and cube root functions are always continuous. Next, we're going to look at end behavior. So what are the arrows doing of the graph? So as I look at the left arrow, as x goes to -infinity, that's me looking at the left arrow. And as I look at the right arrow, what do I notice that those arrows are doing? So in this particular picture, the left arrow is also going down slowly. So I'm going to say y is going to -infinity. As I look at the right arrow, I can see that it's going up slowly. So y would be going to +infinity. So these graphs, they're very, very similar, pretty simple. You're going to notice that the answers that are a little bit boring for these graphs are domain and range, because the arrows always go left and right. The arrows always go up and down. So those domain and range answers are never going to change. They are always going to be this boring. The increasing and decreasing intervals are also going to be kind of boring, because these graphs always do one or the other. They never do both. So one of the answers is always going to look like this, and the other answer is always going to look like that. So these should be some pretty simple equations for you guys to look at today.